In this section, we will compare two of the most widely used temperature sensors in the industry, thermocouples and RTDs, or resistance temperature detectors. We will explain how they work and their main advantages and disadvantages. Let's start with thermocouples. A thermocouple is a temperature sensor made of two different metal wires joined at one end, called the hot junction. This hot junction is located at the point of measurement. The other end has the cold junction, which usually remains at room temperature. When the hot junction is heated, a small voltage is created between the two wires due to the Seebeck effect. This voltage is measured at the cold junction and is in the millivolt range. Finally, using calibration tables, we can correlate the created voltage to the measured temperature. There are many types of thermocouples, being type J and type K among the most commonly used in the industry. The main differences between them are the wire materials, the temperature range, and the temperature curve. For example, for the type K thermocouple, one wire is made of nickel chromium and the other one is made of nickel aluminum. For reference, the characteristic curve that correlates temperature to voltage is shown to the right. Now let's move on to RTDs. They work as a resistor whose resistance increases proportionally to the temperature. In contrast to the thermocouples, this is a single wire sensing element. In the industry, you will most likely find a PT100 or PT1000, where the PT stands for platinum, the material of the wire. As an example, you can see the characteristic curve of a PT100 to the right, where resistance increases linearly with temperature. As the main characteristic, the resistance is 100 ohms at 0 degrees Celsius reference. For the case of a PT1000, it would be 1000 ohms. Finally, let's discuss some of their advantages and disadvantages based on four aspects. The first aspect is the range. Thermocouples can measure higher temperatures, usually up to 1000 degrees Celsius or above, even up to 1800 degrees Celsius, depending on their type. RTDs, on the other hand, can measure usually up to 200 degrees Celsius, although some manufacturers offer special designs up to 600 degrees Celsius. The second aspect is the accuracy. Thermocouples have an accuracy of approximately plus or minus 2 degrees Celsius, in contrast to plus or minus 0.5 degrees Celsius for RTDs. So you can see that RTDs are much more accurate. The third aspect is the response time. Thermocouples respond much faster to changes in temperature, usually in less than 1 second. RTDs, on the other hand, need up to 5 seconds to respond. The fourth aspect is the cost. Thermocouples tend to be cheaper than RTDs, but RTDs still remain competitive and are widely used. As a final word, please note that neither is necessarily better than the other. It really depends on your application and which aspect you want to prioritize.